So I'm going to introduce you to the word element. Okay. So this is an element. Okay. And then we have our transformation. And on the element, we have planes. Okay. So over here, this is known as your YZ plane. This surface over here is known as your XY plane. And this surface over here is your XZ plane. Okay. Now your plane, what we have over here, this is known as our in plane. And the other two is our out of plane. Okay. So if we were to draw this in a different orientation now, so if you look over here, the transformation we use is still the same. This is known as our XZ plane. And over here, this is our YZ plane. And over here, this is known as our XY plane. In this context, over here, this is our in plane, and this is our out of plane. Strongly encouraging you all to play a lot of computer games if you can. Now, when is it in plane and when is it out of plane? Anyone? Anyone? When you classify an element surface and in plane, when is it an out plane? Start Googling it or start reading textbook, but don't waste your time reading textbook. I started reading textbook, I cannot find any information on it. Okay, it seems to be known. So what can you tell me? When is it in plane? When is it out of plane? Think simple. Anyone? Anyone? Yep. Well done. Think simple. Okay, so the in plane is the surface with the largest area. No more and no less. Okay. There are two terms that I want you to learn now. One is known as plane stress, and the other one is known as plane strain. Okay. So what do I mean by the term plane stress and plane strain? Now, given the same element, same transformation, over here, the stress is acting perpendicular to the surface. We call it normal stress. Okay. So plane stress condition is where stress X and stress Y are not equal to 0. Stress Z is equal to 0. It can be also be stress X and stress Z is not equal to 0. stress Y is equal to 0. And it can also be stress Y and stress Z is not equal to 0. Well, stress X is equal to 0. This is how we define plane stress, okay? Some of you who are going to take finite element modeling for your technical elective, you have to know this. Those of you who are not taking it, you also have to know this because of 303 and this course. Are we clear? So that is what we define as plane stress condition. Now there's another condition that we have to deal with, which is known as plane strain condition. Now, if plane strain condition, now we draw the same element. Now we have strain in X, strain in Y, and strain in Z. When we have plane strain condition, okay, plane strain conditions specify that strain in X and strain in Y is very much greater than strain in Z. However, stress in Z is not equal to 0. Or if it means strain in Y and strain in Z is so much greater than strain in X, where stress X is not equal to 0. And the last one, as you can see, it can be strain in X and strain in Z is so much greater than strain in Y, and stress in Y is not equal to 0. Okay, so when they specify what is plane stress, what is plane strain, you have to know. Okay. Anyone have a marker? Yeah, on the left hand side is plane stress, right hand side plane strain. Yeah, it's okay. Anyone have a marker? It's big. What is an element in real life? We somehow have to relate this element in real life. What is an element in real life? Did I make a mistake over there? I think we're fine. But what is an element in real life? Right? We're talking about elements. What is in real life? What is the stress acting on this wall? What do? You put strain gauges in one direction. So you physically put strain gauge in one direction. And if we were to call this X and Y, these will measure what direction? What direction? X direction. And then if we do a vertical direction, this is known as our stress in what? Y direction. Then from here, depending on how the structure is blown, right, you will have a change in strain. With this change in strain, you relate to your stress. Now you construct an element. Over here is known as the stress X, and over here you know as your what? Stress Y. This is my teaching aid. Whenever I teach you, I don't need to draw it again. Are we clear? Right. So what we are going to do next, which surface is the most important? Is it the in-plane surface or the outer plane surface that's important? Where will fracture occur? Okay, where will fracture occur? I'm going to pass around chalk. I know that you guys pay a lot of money for your course, and what you get back in return is chalk from me. Okay. So, and every alternate student have a piece of chalk. Okay, if you have one, the person beside you will not have one. You two will share. Okay, so I'm going to pass the chalk around. Your hand up, hand in hand, the chalk, and one another. Okay, and we're going to do an experiment. Anyone allergic to chalk? You can accept it. Okay, I'm going to go the other side. Next time I'll buy more chalk. Okay, if any of you are allergic to chalk, let me know. I was worried here. Okay. Okay. You have a chalk. You have big responsibility now. Okay? Now we are going to do this now, okay? Are you all ready? Those of you with a chalk, we are going to do this now. Okay? This is more fun than buckling. What we are going to do is those of you chalk, this is your chalk, and this is your Y direction, and this is your X direction. What I want you to do is to use your pen to draw an element on your chalk. So now I'm going to draw an element on my chalk. I hear a chalk broke. Who is that? Okay. So I'm going to draw my chalk. An element. Can you all see an element? Yes or no? Okay. Can you draw an element like what I've just done? Yes or no? Okay. Then I want you to play in one direction. Okay. Draw an element. Then I want you to name a direction, and it's going to be known as stress X. Okay. Now, what are we trying to address here? What are we trying to address here? Which plane is what? Important. Or which plane will what? A fracture. Yes or no? Right? So the XY plane, which has the biggest area, is our what? In plane. We know our XY, sorry, our XZ and our YZ, the outer plane is not drawn down here because it's impossible to draw into the chalk. So now what I want you to do now, have you all drawn the square? You all done that? Okay. Don't do anything. Watch me. So this is a chalk. A chalk is meant to be brittle. If I press it, I can't break it at all. When I say press, induce axial load. Okay. Now, if I do pull, ooh, and you pull your chalk. Oh. What do you think? What do you see? This is a chalk from another student. What do you see? Where is fracture going to occur? So as you can see, what we have just done down here, if we draw this in 3D, right? And this is our X, and this is our Y, and this is our Z, okay? Fracture will occur on this surface over here. And this surface is your what? Is your YZ plane. And your YZ plane is what? Of plane. If we were to induce a stress on